All right, Year 11s, welcome to the next part of our Year 12 content. Last lesson, we learnt about, what did we learn about? Oh yeah, that's it, standardized scores, so Z scores. And then prior to that, we learnt about that 68, 99.95 and 99.7% rule, all relating to univariate data, okay, and Year 12 content. But now we're going to be going into bivariate data for the Year 12 part. So just a quick recap on what we learned with bivariate data last year. This year. So bivariate data with a linear equation can be modeled by a least square regression line. So remember, with bivariate data, we looked at scatter plots. So if you forgot what a scatter plot looked like, it's like this. Okay, you've got a X and Y variable of some sort, and then you've got a bunch of dots. And we talked about different things. Yeah, you remember with these sorts of graphs, you could have lines like this, where this line is called a least squares regression. Okay, and we use this line to make predictions. Let's say, for example, the line rule was 2x plus 1. Okay, and we use this to make different predictions, like say, for example, if x was like 3, so times 3, what would the value be? Well, the value would be y equals 2 times 3 is 6 plus 1 is 7. Okay, so in that case, if x was 3, y would be 7. All right, so that's how we sort of used that line. We also interpreted the line, okay, by making interpretations on the x-intercept, the y-intercept, and the gradient, which is this. So don't forget that. So in this formula here, just a heads up, if you've forgotten, this formula is the same as y equals bx plus a, or a plus bx. It's the same thing, yeah. But this refers to the gradient or the slope, and this referred to the y-intercept. Okay, so some things to remember with this topic. I believe I may have made recordings of this when we started this topic, but I think I did. So you can watch those if you really want to. All right, so just a quick recap as well on how do we do all this on the CAS. Rather than me perhaps reading through all of this, you can refer to this again if you want to, but I'll just show it to you on the CAS. All right. So if you wanted to, for example, graph these lines on a scatter plot, or these plots on a scatter plot. So you would obviously need to first put your data in, like so, label your column. All right, so that's temp, that's aircon. Okay. To get to this point, by the way, you would go, let's go current. You'd go Control I. So Control I opens up a new page, and you do list and spreadsheets, but we don't need that for now. So I'm going to close this. Page. All right, so don't need that. All right, so we're looking at this. How do I make this into a scatter plot? So let's go Control I. Okay, and then we'll go data and statistics. All right, so remember, what's your EV and RV, or what's your X variable and Y variable? In this case, if you look at it, temperature should determine the aircon, okay, or the how cold you'll make the aircon. So temp will go on the EV or the X, and then aircon will go on the Y variable, the RV. All right, so there's my scatter plot. Okay, I think that's what else does it ask us to do. Okay, from there, we need to make a linear regression line, or least squares regression line. So to make the line, okay, we go menu, plot properties. Plot type. Actually, let me make sure this is in the middle. Menu, analyze, regression. Okay, so remember that. I'll do that again. And pay attention to the detail and making sure that cursor is in the middle. Menu, analyze, regression. Okay, and then we're looking at a plus bx. Right, and that should give us the formula. Right there. So there's my formula. Negative 29.0639 plus that. So 1.5308x. This is the y-intercept. This is the gradient. All right. Okay, I think that might be it for that. Okay. Also, you can probably do that on your CAS without having to draw this graph. So if you go back here, you can actually find all of that if you do it in here. So let's go menu again, statistics, stat calc, a plus bx. So this was temperature for the x variable, and aircon was the y variable. Yeah, and there's your a, and there's your b, which is what we had for here. This is a, negative 29.06, and that should be 1.5008 or 53008. Oh, and also remember what these were: r squared value and r value. All right, quick reminder: r value is your coefficient of correlation. So the higher the r value, the more closely the dots are. And r squared is how well the coefficient of determination, which is how well the R value represents or basically explaining how well the data represents what the values are. But let's not get into too much detail with that so it doesn't confuse you guys. All right, so let's go on to the next part. So let's do some questions to refresh your mind on this. So an appliance store learns that the number of air cons they sell each week is predicted by the average daily maximum temperatures in that week. The data used to support this is given below. So here's my data here. You've got temperature and aircon sales. So let's put this data, the question is find the equation of the least squares regression line that predicts the air conditioner sales for the maximum temp. Okay, round the intercept and slope to 3 sig figs. All right, so for this question, you got to make sure, okay, that you obviously use your calculator for it, but that you understand which is your EV and which is your RV. The good thing is this sort of tells us already. So yeah, EV is X, which is temp. RV is Y, which is aircon sales. Now, this is part of the data that I've put here already. So I'm going to just finish that off. We've got 21, 23, 25, 28, 30, 32. So up to 32 now. 32, 35, 38. And for the Y variable, it should be 23, 25, 20, 37. All right, so putting that in my scatter plot. So just double check this, because then that will make sure that all the new plots that you put are in there. So there's my scatter plot now. Now the question here is find the equation of the least square regression line. It's right there already, which is nice, but you can probably do it here as well. So just as a shortcut, you can actually find the formula here now if you wanted to. Making sure that you put the correct variables in. So that's temp, and this is aircon. Okay, and there is my A and B. All right, so if I write that down as my formulas for the least squares regression line, remember the formula should look like this: y equals A plus BX. All right, so if you look at the values here, you'll know that y equals A is negative 37.565, and it says 3 sig figs. So I only want 3 important numbers, which would be 3, 7, and one number after that point. So negative 3, 7 point, that 5 will become a 6 because that 6 will affect the 5. So 37.6 plus the slope. So slope represented by B right there. 1.87295. So I want 3 important numbers, 1, 8, and 7 there. 1.8. Now that 7 won't get affected because the 2 won't change it. 7x. Now, if you actually wanted to write this formula the proper way, after that you would change x and y, so these x and y, to these variables. So it should be aircon sales is equal to negative 37.6 plus 1.87 times the temperature. Okay, that would be the proper way of writing the formula as a final answer. Okay, but we don't need to do that. But just something that you should know. All right, B says predict the number of aircons that will be sold if the average maximum temp is 27. Round your answer to the nearest whole number. So what we're looking for here is what would the aircon sales be if temperature was 27? Alright, so let's work it out. Just use your calculator for this. And you can basically, if you want, I'll do that here 2 times 27. Okay, but yeah. You can actually just use your solve function for this. So if you want, you can go add calculator. And then you go solve. Y equals negative 37.6 plus 1.87 multiplied by 27. Okay, and comma y. I want to figure out what is my aircon sales going to be. So the answer is 12.89. So on my calculator, this is what I did. Yes, solve using my formula. Oops. So using this formula here, okay, and I just changed x to 27. I went solve, bracket, y equals negative 37.6 plus 1.87 times 27, comma y. Okay, because I'm looking for the y variable. So that means the number solved, which is 12.89, not quite the final answer yet. Round it to the highest, the nearest whole number, which would be 13 aircons. All right, 13 aircons sold. All right, next example here. So we're looking at the relationship between heights and weights in kilograms. So of a group of people is investigated that aims to predict the weight from their height. The data gathered is given below. So here's my data. Okay, I've actually already done this on my CAS. So kudos to me for doing that. So let's get rid of all this. Okay, so you got to put in your EV and RV. So obviously start off by writing down your the label for your columns. I've already done this before, so that's why the values have popped up. Okay, so let's find the equation of the least squares regression lines. Let's do that. So let's go menu, statistics, stat calc, a plus bx. Remember, what's your EV? In this case, it's height, and my RV was weight. Okay, and there is my A and B. So remember the formula. Okay, it should looks like this: y equals A plus bx. All right, so that means formula should be A, negative 84.82. It says 3 sig figs as well, so negative 84.3 plus my B is 0.867. So I'm looking for 3 important numbers, 8, 6, and 7. Actually, yeah, that's it. Times x. Or you could just leave it as x. That works too. Okay, part B. Predict the weight of the person whose height is 175 centimeters. Round your answer to the nearest whole number. So what's the weight, which is the RV, if the height was 175? So in your calculator, you'd go solve y equals negative 84.3 plus 0.867 times 175, comma y, because I'm looking for the y variable here. All right, so put it on our calculator. Solve y equals negative 84.3 plus 0.867 multiplied by 175, comma y equals 67.425. So the decimal answer 67.425, and it says round to the nearest whole number, so that means it should just be 67 kilograms. All right, pretty straightforward, right? Let's go through the main bulk of what we're doing today, which is transformations, which is related to obviously what we just did then. All right, so for transformations, associations between variables may not be linear, which means that sometimes you might have a graph that's not necessarily linear. Like it could be curved like this. Okay. Least squares regressions cannot be meaningfully performed on non-linear data, which means that if you're to draw a line here like this, it wouldn't really work. Why? Because it doesn't really represent the data that well. Okay. So if I wanted to draw a straight line, it doesn't account for everything in this data. Like a better line would be a curved line, right? But we want a straight line. Okay. Obviously it's not going to work very well with this data. So what can we do? Well, what this transformation is basically if you have a line that's non-linear or a bunch of scatter plots that are not linear, the transformation, well, actually, what it does, so this transformation, what it does is it makes it straight like this. Okay, it makes it into a linear graph. And it does that by making transformations on your x variable down here, or your EV, or your y variable. So they do some sort of change, whether they divide the numbers, they multiply the numbers, or they square the numbers. Okay, and what happens is when it transforms it, okay, the variables, for example here, the x variable could get squared, and that might make the line, the scatter plot, a lot more linear. Okay, so that's what a transformation is. So to perform a least squares regression transformation on nonlinear bivariate data, we need to transform the data that the association is linear. So what that's saying is we need to transform the data to make it linear. There's three kinds. We use a squared transformation, log transformation, or a reciprocal transformation, and you'll see all of that down there. Okay. Each transformation can be applied to the EV or the RV, like I said. So you can apply transformation on the EV or the X, on the RV on the Y, and it will make the data linear. Right, and these are the different transformations. So you can square your transformations or your variables like that. You can log your variables, and you can also do a reciprocal on your variables, which just means it's 1 over the variable, or 1 divided by your variable. All right, let's try this out. Oh, actually, you can see this in the calculator here. I think there's so we'll get we'll do a transformation here, starting on 5B. All right, so you can see here some examples of what you can do. I might actually just do this on the calculator now, so you can see how it works, all right? So on my calculator, I'll use the variables that it has here. I'll make some new ones too. Actually, you know what I will do? Because there's a lot of variables already that I've made here. I will make a new one. Sorry, guys. Make a new one so there's not that many happening. No. Okay, this in spreadsheets. Here we'll get time. So these obviously I haven't done yet. And we'll get 0, 2, 4, 6, 8. Then you got 1560, 1540, 1482, 1383, and 1246. Now, maybe before I go ahead, I want to show you guys what this data is going to look like if it's not transformed. So let's see what it looks like on the data and stats. So here we've got time, I think it was, yep. And we'll go with height here. So you can see that the data isn't quite linear. It sort of curves downwards, doesn't it? So what we want to do is try and make this data a bit more linear, okay, by doing some sort of transformation. So the transformation that they're going to do here, you can see is going to be a squared transformation on time. Okay, so what we'll do is on time, we're going to call this column time squared, or time SQ. And in the second column here, second row, you're going to press equals. Okay, this is where you do the transformation. So you want to do a transformation on time squared. So what you're going to do is type in time to the power of 2. Or you can also use x squared there. So what that does is it's going to square all of these values here. See? 2 squared is equal to 4. 4 squared is 16. 6 squared is 36. 8 squared is 64. Now, going back to my scatter plot, if I use time instead of time squared instead of time, watch what happens. See how now the data is linear. So we can actually now use this to make predictions. Okay. All right. Let's actually do an example here from 5b. See if you can, so we can actually see it in context. All right, so let's look at some examples for this. So we're going to do squared transformations on the EV, so on the X variable for these ones, okay? A base jumper jumps from the top of a cliff 15-16 meters above the ground. Her height at each second is measured. The squared transformation is applied to the variable time. Okay, so we need to, I've already gone through the liberty of putting the variables in here for you, so you don't have to watch me do that. But here, I will be doing a transformation on time. Okay, I'm not going to graph this just yet. I'm just going to focus on my list and spreadsheets here. So let's do a squared transformation on time by this. I like to put a space in between each variable, so it's not too confusing. So here we're going to call this time SQ, or time squared. Okay, and then here in the second row, press enter, and you're going to square time. Yes, you're going to go time to the power of 2, or you can write x squared there, so squared, enter. And what that does is it squares all of the x variables, or the EVs, right there. Height hasn't changed, yeah, so I've only just squared time. So now from there, we need to write down an equation where instead of using normal time, we're going to use time squared for the x variable, or the EV, and we'll use the normal height for the RV. All right, so put your cursor here a bit to the right. We're going to get menu, 414. X is time squared, y is going to be just normal height. Okay, so there is my formula for if time was squared. So if you write down your answer for A, should look like this. Y equals, look at A there, is 1559.86. Oh. It does say 4 significant figures, so that will round up to 1560. So just double check to read the question. Also, just a note, it might be worth also just highlighting the number so you can see underneath here what it is exactly. Okay, so it's 1559.86. So we're rounding this off to 1560. Cool. And then my A, so remember for my A plus BX, Y equals A plus BX. So what's B? In this case, B is negative 4.9. So it's going to be negative. And it says here, we're going to round it to 4 sig figs. So 4.900. Remember, any 0 after the decimal point at the end is important. So these 2 zeros are important. That 7 influences that 0. So it becomes 4.901x. Okay, so there's my formula. Or actually x squared, because remember, time is going to be squared. So I've squared my x variable. All right, so there's my formula. Now, part B asks me to make a prediction on the person's height if their time was 7 seconds. So we're going to change x to 7 in my formula. So in my calculator, we're going to do this. Solve y equals 1560 minus 4.901 times 7, comma y, because I'm looking for my y variable, all right, which is the height. So let's add a calculator here. All right, so solve bracket y equals 1560, take away 4.901 times x squared times 7 squared in this case, and then comma y. All right, and that should give me 1319.85. So at 7 seconds, the height is 1319.85. Round is to 4 significant figures, 1319.85. that 8 will make that 19 a 20, so 1320 meters. And that makes sense because at what was it, 7 seconds, it should be between these two, between 6 and 8. 1383, 1246. Oh, that's 1320 is in between them. Okay, guys, so we're going to go to the next one, but instead of doing the same example on the same transformation on time, or on the X or EV, we're going to do transformation on the RV instead. So same question, but this time a transformation on height. So the same one. Now we're going to do the equation for this scenario, but with a transformation on height instead of time. So let's go to, where did I go? Okay, so let's go to our calculator. We've got our variables, which are the same as the previous question. This time, let's do a transformation on time. So let's go height. So let's call that height, or height SQ, sorry. And as you can see, I've actually already done it. So, but I'll show you again how it's done. So you press equals here. You go height to the power of 2, x squared. Okay, and that will give you all of these values. Okay, so let's get rid of that. Don't need that anymore. And there is basically my height squared. So instead of squaring time, I've squared height this time. All right, so now the next part is to make a formula for this. So it's going to be A for the formula y equals, actually, let's put this all down here. All right, so let's go menu 414. Remember, X or EV, which is time, has not changed, so we're just going to leave it as time. The RV, which is Y, we've squared that, so that will be the formula there. So in terms of writing down the formula, remember just to double check the numbers, don't write your A as 2.5 as it says here. A is 2591299. So my formula, Y squared equals 2591299. I'm going to skip the decimals because it does say nearest whole number and that 1 doesn't affect the 9. So take away, and my value for B, remember it's y equals A plus BX. That's going to be negative 131,205. Oh, actually 2086, because that 5 will influence that 5. X. So there's my formula. Now part B is going to ask us to make a prediction on what the height is going to be, as you can see, after 5 seconds. So we're going to just change X to 5. So on my calculator, you're going to solve, okay, solve for Y. Solve for Y squared, sorry, so solve for Y squared, comma, a bracket, Y squared equals 251,299. Actually, I skipped a number, sorry, 259,1299. Don't skip any numbers. Take away 131,206 times 5 seconds, yeah, because we're looking at it for 5 seconds, comma, Y. All right, so let's type that into our calculator. Solve. 259,1299. Oh, sorry, I forgot to put the Y squared. Don't forget that, that's important. Y squared equals 259,1299. Yep, take away 131,206 multiplied by 5, comma, Y. Oops. Comma, Y. Okay, now if you get this, just press Control Enter. There's your final answer. Okay, so Y equals 1391.14. So that means at a height of at 5 seconds, he's going to be at a height of 1391 meters. So as you can see, 5 seconds again falls in between those. All right, that's going to be it for 5B. 5B. I'm going to get you guys to go on and do your exercises for chapter 5B. It's only 2 questions for these ones. Yeah. Thank you very much. Have a good one.